Good morning to one and all. Myself Dr. Ramgopal, Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Let us recall the previous session. In the last session, we have discussed testing of hypothesis concerning proportions, in particular one proportion for large samples and problems on the same. And coming to the today's presentation, today we are going to discuss the testing of hypothesis concerning two proportions for large samples, and we will solve some problems on the same. Now, the test of hypothesis concerning two proportions for large samples. That means there are two populations, population 1 and population 2. From each population, we draw the samples, for example, of size n1 and n2 from population 2. Then we calculate the proportions capital P1, capital P2 for population 2, and we test whether these two population proportions are the same or not. So, before going to discuss the actual test, suppose there are two distinct populations capital A and B. Let each item of this number of these two populations belongs to two mutually exclusive classes. For example, the attributes having the attribute C and without C, we can consider that as success and failure. And let us consider the following table. The classes having attribute, that means the success, and without success, which is called failure, and sample from population A, sample from population B. For example, a sample of size n1 is drawn from population A, and out of n1, let us suppose x1 be the number of successes, so which comes under item having attribute. If there are x1 successes out of n1 trials, then n1 minus x1 must be the failure, number of failures, and this last column gives the total. Similarly, from sample B, let us draw a sample of size n2 from population 2 or population B, and x2 be the number of successes, then n2 minus x2 is the number of failures, and the final column shows the totals, and the grand total is n1 plus n2. We consider these values in testing of hypothesis concerning two proportions. So, here we test whether there is any difference between the two proportions or not, and the test is as follows. The first one, null hypothesis, H naught is capital P1 minus capital P2 is 0. That means there is no difference between the two population proportions. And alternative hypothesis, any hypothesis other than the null hypothesis is called alternative hypothesis. Hence, there are three types, either P1 minus P2 less than 0, that means P1 is less than P2, P2 is better than P1. Similarly, P1 minus P2 is greater than 0, so P1 is greater than P2, and similarly P1 minus P2 not equal to 0, the third case. There are three types of alternative hypothesis. Next, level of significance will be given in the problem, 5% or 1%, the most general values, and the critical region. To reject the null hypothesis, we consider these conditions, and these are the same conditions that we have applied in means problems and even in one proportion for large samples. So, again the conditions are the same, and the calculation part, in this part we consider the test statistic. So, Z calculated is given by the difference between the two proportions P1 minus P2 by standard deviation of sampling distribution of difference of proportions, and using the values, and after simplifying we get Z calculated is given by x1 by n1 minus x2 by n2. So, that means the proportion 1, proportion 2, the difference between the sample proportions divided by p cap into 1 minus p cap into 1 by n1 plus 1 by n2. This p cap is given by simply x1 minus x2 by n1 plus n2, and by comparing the calculated value Z calculated and Z tabular value, we can take the decision whether to accept the null hypothesis or to reject the null hypothesis. And coming to the first problem, if 57 out of 150 patients suffering with a disease are cured by allopathy and 33 out of 100 patients with the same disease are cured by homeopathy. Now the question is there any reason to believe that allopathy is better than homeopathy at 5% level of significance? So here there are two populations, population 1, population 2. One comes under allopathy and the other homeopathy. Here the sample 1, N1 is out of 150 patients, 57 got cured. So X1 is 57. Similarly, out of 100 patients, so N2 equal to 100, 33 got cured using homeopathy. Now we need to check whether allopathy is better than homeopathy at 5% level of significance or not. And the test is as follows: the null hypothesis H0. Here the question is there any reason to believe allopathy is better than homeopathy? I will consider this allopathy as 1 and homeopathy as 2, the suffixes. So small p1, small p2. Similarly, capital P1, capital P2. The null hypothesis is we consider there is no difference between the allopathy and homeopathy. So P1 minus P2 is 0. There is no difference. And we test this against the alternative hypothesis not equal to P1 minus P2 not equal to 0. And there is no such information or question given in the problem that allopathy is better than homeopathy or homeopathy is better. It is given in the question itself, it is given allopathy is better than homeopathy. So that means the alternative hypothesis should be P1 minus P2 is greater than 0. That means P1 is greater than P2. So allopathy is better than homeopathy. So such hint will be given in the problem. According to that, we consider the alternative hypothesis. And level of significance alpha also given 5%, so 0.05, and critical region it is greater than type. So reject H0 if Z calculated is greater than Z alpha. For 5% level of significance, Z alpha is 1.645. In greater than type, it is 1.645 Z alpha, the tabular value. Let us calculate Z calculated value using the test statistic given by x1 by n1 minus x2 by n2 divided by under root p cap 1 minus p cap into 1 by n1 plus 1 by n2. First we need to calculate this p cap, then substitute that value here. So by substituting all these values, here we will get p cap as 24 by 25 and we have x1 237, x1 is 57, x2 is 33 and n1 given 150, n2 100 and p cap we will get we obtain using that formula. P cap is 0.36 and substituting all these values, the Z calculated value is equal to 0.36 or 0.81. After substituting all these values, we will get the calculated value 0.81 and we have the tabular value 1.645. So the decision, final decision we can take by comparing these two values. 0.81 is less than 1.645. So Z calculated is less than Z alpha. If Z calculated is greater than Z alpha, we reject the null hypothesis. But what we got here is Z calculated value is less than tabular value. Therefore, accept the null hypothesis H0. Since the calculated value is less than that of tabular value, we cannot reject the null hypothesis. So we have to accept it. What is the null hypothesis? There is no difference between homeopathy and allopathy. This is the final conclusion. And coming to the next problem, in a supermarket there are two vending machines in which the first one fails to work 13 times out of 250 trials, and the second machine fails to work 7 times out of 250 trials. Test at 5% level of significance whether the difference between the corresponding sample proportions is significant or not. So, here the alpha is given again 0.05, and there are two populations, and from the two populations we have considered two samples. So, N1 equal to 250 and another N2 also 250, and X1 out of 250 times 13 times failed. So, 237 times it worked. Similarly, the second machine 7 times, so 243. And we need to test whether there is any significant difference between the two sample proportions or not. Coming to the test of hypothesis, the null hypothesis H0. There is no difference between the two population proportions. There is no difference between the two population proportions, and nothing claim is given in the problem. That is why we test this null hypothesis against the alternative hypothesis not equal to 0. Level of significance is 0.05 and critical region not equal to type. So, reject H0 if Z calculated is less than minus Z alpha by 2 or Z calculated is greater than Z alpha by 2. So, for 5% level of significance, plus or minus Z alpha by 2 is plus or minus 1.96, and the test statistic is given by Z calculated value P1 minus P2 by sigma P1 minus P2. First calculate this P cap and then substitute. So, after substituting all these values, we will get minus 1.3698. So, that means we got a negative value. So, compare this negative value with the negative tabular value. Since minus 1.3698 and minus 1.96 is greater than, so Z calculated is greater than minus Z alpha by 2. With the negative value, the condition must be Z calculated is less than minus Z alpha by 2. But what we got here, Z calculated is greater than minus Z alpha by 2. If it is less than, we can reject the null hypothesis. Otherwise, we have to accept H0. That means there is no difference between the two population proportions. And coming to the summary of the present session, in this session we have discussed test of hypothesis concerning two proportions for large samples. Here we apply Z test since it follows the standard normal distribution, and we have discussed two problems also, and in the next session we will discuss about the test of hypothesis 2 that comes under test of hypothesis for small samples. Again, one mean and two mean problems and one proportion, two proportion problems for small samples. Thank you very much.